when I have a quadratic trinomial, quadratic meaning x squared is my highest degree, and trinomial meaning there's 1, 2, 3 terms, and the leading coefficient, it has a leading coefficient, it has a number in front of the x squared. This is the technique I like to use. I take my leading coefficient and my constant term and I multiply them together. I take my 2 times my negative 3 and I multiply them together. And then I look for a pair of numbers that multiply to negative 6 and add up to negative 1. That 1 I put in there, right? It said negative x, but that's the same as negative 1x. So I think about my numbers that multiply negative 6, like 1 and negative 6, 2 and negative 3, 3 and negative 2, 6 and negative 1, and I look for the ones that multiply to, that add, to negative 1. So 1 plus negative 6 is negative 5, that's not what I'm looking for. 2 plus negative 3 is negative 1, winner. 2 and negative 3 are the numbers I'm going to use. I use those, unlike the easy version of the problem where there's no leading coefficient. In this version of the problem, I could just throw 2 and negative 3 into parentheses. When there's a leading coefficient, I use these to rewrite the problem. I rewrite the problem. The problem is 2x squared minus 1x minus 3. But instead of minus 1x, I write plus 2x and minus 3x. Those numbers coming from the numbers I found over here, 2 and minus 3. And now that there's 4 terms, I factor by grouping. Out of the left side, I can take out a GCF of 2x, and that leaves behind an x plus 1. Out of the right side, I could take out a GCF of negative 3. Negative, because it was negative, start with a negative up here. And when I take out that negative 3, I'm left with x plus 1. So overall, this factors to x plus 1, 2x minus 3. X plus 1 from here, and 2x minus 3 came from up here. So we'll try that again. Here, I have to multiply my leading coefficient and my constant term, and I get 4. By the way, the first thing I should do is look for a GCF. There was no GCF in the last problem, there's no GCF here, but first thing I do is look for that. So I multiplied my leading coefficient and my constant, and I got 4. And I'm going to look for what multiplies to 4 and adds up to negative 5. I could do 1 and 4, or negative 1 and negative 4, or 2 and 2. All of these pairs of numbers multiply to positive 4. And when I add them up, 1 plus 4 is 5, negative 1 plus negative 4 is negative 5, 2 plus 2 is 4. I really don't need to keep going because I found the number I'm looking for. I'm looking for something that adds up to negative 5. Negative 1 and negative 4 do that. So I rewrite my question. I rewrite it 2x squared I rewrite it like that. Negative 1 and negative 4 coming from here. The reason I'm allowed to rewrite that is because if I think about it, negative 1x minus 4x is going to make negative 5x. I didn't change the problem. It still says negative 5x. It just says it in 2 pieces now. Now that it's in those 2 pieces, I cut the problem in half, and I do factor by grouping. Out of the left side, I could take out an x and be left with 2x minus 1. Out of the right side, I could take out a negative 2, and I have 2x minus 1. The fact that this and this match is lovely. It means that I'm going to have 2x minus 1 times x minus 2. X minus 2 from here and here. We'll try another one, if I can find another one. This looks like another one. Oop. Try again. There we go. First thing I do is I look for a GCF. 4, I can only divide by even things. 9, I can't divide by even things. So there's not going to be GCF there. I take my leading coefficient and my constant. I do 4 times 9. I get 36. I think of the numbers that are going to add up to 20, positive 20, and multiply to 36. I just keep thinking of all the different factors. And I can stop when I actually find one that adds up to 20. So I could have stopped way up here. This adds up to 20. I'll use those numbers to rewrite this. 4x squared plus 2x, 2 from those numbers I found, plus 18x, 18 from those numbers I found. It doesn't matter the order I put it in. I could have done the 18 here and the 2 here. It doesn't make a difference. Either way I do it, I now have 4 terms. I cut the problem in half. Out of the left side, I could take out a 2x and be left with 2x plus 1. Out of the right side, I could take a plus 9, and I'm left with 2x plus 1. So overall, I have 2x plus 1, 2x plus 9. Last one. Here, oh, these are big numbers. I do not look forward to multiplying 2 and 28. Good for me is I don't have to, because first, I can factor something out. I can factor out a 2, and I'm left with x squared plus 10x plus 14. So then all I have to do is factor this, and this is the easy version of quadratic trinomials. This is the version where I'm just looking for something that multiplies to 14, adds to 10, and I just put that in parentheses. Something that multiplies to 14 and adds to 10. Oh, what a letdown. None of them do. That's such a bummer. Let's change the problem, because I was so looking forward to having it work. Let's instead do 2x squared plus 18x plus 28. I still have a GCF, so I'll still take out that GCF. And I still now know I need to factor this, and it's going to factor into something that looks like something times something, and it'll have a 2 in the front. And because it's the easy version of quadratic trinomials where there's no leading coefficient, I don't have to do a weird factor by grouping process. I know it's going to look something like this, and I just fill in this blank and this blank by looking for something that multiplies to 14 and adds to 9. So, multiplies to 14, I could be talking about 1 and 14, or 2 and 7, or -1 and -14, or -2 and -7. 2 and 7 are the numbers I'm talking about, because those add up to 9. So I'll put a plus 2 here, and a plus 7 here. This multiplies to this. The 2 is still out front. So my final answer is just that, 2, x plus 2, x plus 7. This problem, this inside did not factor. My final answer in this problem would be 2, x squared plus 10x plus 14.